afternoon, or evening, whichever time it is that you are watching this video. This is Unit 10, Graphing Rational Functions, Lesson 3, Asymptotes and Graphing Rational Functions. Our objectives today will be to identify vertical, horizontal, and slant asymptotes as well as holes in rational functions. We're going to use the vertical, horizontal, and slant asymptotes, holes, and x and y-intercepts in order to sketch some graphs of the rational functions. Okay, first, what are these asymptotes we're talking about? Well, an asymptote is a line that a graph approaches but does not touch. On occasion, with horizontal and slant asymptotes, a graph may cross the asymptote, but it will then come back and ride right along next to it. We'll see that in some of our examples. And first, a vertical asymptote. A vertical asymptote is a vertical line, you write it x equals, and then the number, which the graph of a function approaches but never reaches. It occurs when the limit of a function, as it approaches a number from left or right, or at the number, equals either positive or negative infinity. Essentially, a vertical asymptote occurs any place where that particular number, if input into the function, would make the function invalid. To find the vertical line, we set any factor in the denominator equal to 0. The equation will be x equals that value. It is possible to have multiple vertical asymptotes. It's also possible to not have any. Now, a hole or point of discontinuity. A point where the graph of the function is undefined is considered a hole or a point of discontinuity. A hole occurs when a factor of q of x, the denominator, cancels with a factor of p of x in the numerator. The x value is determined by setting the q of x factor equal to 0 and solving for x. The y value is determined by substituting the x value found into the simplified function. It is also possible to have multiple holes. So you can have more than one vertical asymptote, you can have more than one hole or point of discontinuity. The example is going to make it much easier to see these, but these are the written definitions. A horizontal asymptote is a horizontal line, written y equals a number, which the graph of the function approaches. A horizontal asymptote may be crossed, but the function will curve back and approach the value from the opposite side. It occurs when the limit of the function as it approaches a number from left or right of the number equals either positive or negative infinity. There can only be, at most, one horizontal asymptote. If a horizontal asymptote exists, there will not be a slant asymptote. And by the way, only Algebra 2 trig worries about slant asymptotes. Algebra 2, you're just horizontal and vertical. To find, make numerator and denominator have the same degree. That means one of them you might have to make 0x to a power. Then set y equal to the lead coefficient of the lead coefficient. If 0 is in the denominator, a horizontal asymptote does not exist, and you may be looking at a slant. Otherwise, you have the horizontal asymptote equation. Slant asymptote. A slant asymptote is a line that is neither horizontal nor vertical. It occurs when the degree of the numerator is one more, just one more, than the degree of the denominator. The equation for the line is this, that is the slant asymptote, is the quotient only, no part of the remainder, found by dividing the numerator by the denominator. There can only be at most one slant asymptote. If a slant exists, there will not be a horizontal. If, when looking for a horizontal asymptote, you get an undefined value, and if the degree of the numerator is one more than the degree of the denominator, you have a slant, and you need to do the division. Now, the best way to do these is by example. If you haven't printed off the notes, please pause and do that now, or grab a piece of graph paper and work alongside me. Okay, so we're taking a look before we even start graphing, and we want to look at the domain. You start by assuming that anything can be put in, but then remember that the domain is your possible inputs. So I have to, let's make sure I'm writing, look at my denominator. And my denominator can't equal 0. If my denominator equals 0, then I can't use that as an input. So I'm going to write x squared, we're going to get this, technology, x squared minus 1 does not equal 0. X squared does not equal 1. That would mean that x cannot equal positive or negative 1 because I take the square root of both sides. So my domain is x is an element of real numbers such that x does not equal 1, x does not equal negative 1. Now, I could also have put x does not equal plus or minus 1. It's really your choice. Okay, so that's my domain. Now, my vertical asymptote, what I'm going to look at is I'm going to take this guy and I'm going to factor the numerator and factor the denominator. Numerator, nothing I can really do. In the denominator, I get x plus 1 and x minus 1. Nothing cancels. Since nothing cancels, all my restrictions, remember our restrictions from Unit 9? All of my restrictions are vertical asymptotes. So my vertical asymptotes are x equals 1 and x equals negative 1. These cannot be written as plus and minus because these are linear equations. So I come over here and at negative 1, I draw my little dashed line here. And at 1, I draw a dashed line. Okay, what it says is my graph can't touch or cross those vertical lines. Because nothing canceled, I don't have any holes. Okay, I'll put nothing cancels. And if nothing cancels, then you don't have any holes. Horizontal asymptote. Okay, the horizontal asymptote, that's where I set y. First, I need to look up here, and I have 2x over x squared. So, if they're going to be the same degree, that means I have 0 x squareds in the numerator. This is bigger, the denominator is bigger, so I need to add 0 x squared in the numerator, and in the denominator, I have 1 x squared. Now I'm going to simplify this. The x squareds cancel, and this leaves me with y equals 0. 0 divided by 1 is 0. So my horizontal asymptote is y equals 0. If you watch other videos, they will probably explain all the rules about when the degree of the numerator and the denominator are the same, when the degree is one more, one less, bigger, smaller. If you just make the degrees the same, force them to be the same using 0 of whatever, it makes it much easier and you don't have to memorize a bunch of rules. Now, you can only have either a horizontal or a slant. Since we have a horizontal, that means that I don't have a slant. X-intercepts. X-intercepts occur when y equals 0. So, in order for this to equal 0, the numerator has to be 0. So I'm going to do 0 is equal to 2x, x is equal to 0. So my x-intercept occurs at 0, and if I plug 0 in, I get 0, 0. So I'm going to plot my x, and oh, by the way, that also happens to be my y-intercept. Now, at this point, you would need to go and either take scratch paper and plug in values, plug in like -2, -3, -4, find out what's happening, plug in -0.5 and +0.5 to see what's happening, and over here. A quicker way to do it, so that you can plot some points, let's see here. And is to turn this on, this just a little bit. Okay, we're going to go to y equals, and I'm going to put in 2x, and then we're going to have divided by the quantity x squared minus 1 And I'm going to go to my table of values. Okay, so if I go to my table of values, I want to find out, notice at 1 and at -1, I have errors. And why? Because those are my vertical asymptotes. At 0, it's at 0. That's where I put my y-intercept. Now, if I look over here, what I want to find out is my graph in this upper half or in this lower half? So I'm looking at -2, I'm at -1.3. So I'm like right around here. At -3, I'm at -7.5. And I keep getting smaller and smaller and smaller. So I'm getting closer and closer and closer. So my graph is going to be up in this section. Then, in between -1 and 1, I can't tell anything because I'm going up and down by ones. Well, before I figure that out, let me go to the far right and see what's happening on the far right. This is at 1.3, and then it comes down to 0.75. So, looking up here, oops, I'm sorry, these are all negative. So I'm going to be down in this section and up in this section up here. And then in the middle, I can go to window, oops, second window, maybe. And now, second, there we go, table set. And I can start at -1, and I can go up by tenths. Now I can go back to my table, and I can see that at -1, I'm down here at 9 something, and I'm getting closer and closer and closer, right? Oops, sorry, I'm up here, and I'm coming down, down, down. And then as I get to my positive side, where am I? I'm on the negative section. So this graph is going to come this way. So now if I uncover this, just because drawing is painful, remember we said we're in the bottom half. We go like this, and here. We just look at the path, and we can see what's happening. And we've got our graph. And all I would want you to do is be able to put in, remember it was negative, at -2, we were at -1.3, and then at 0.75, boom. Here, we realized that we were way up there at 9, and then coming down, right around here. And you get this guy, you know what it looks like. Again, 1.3 something and 0.75, and you can draw your curve. Okay? Now some of these others we're going to go through a little bit faster because otherwise this video is going to be quite long. So next up, example 2. Domain. First, x squared. First I'm going to do -1 over x plus 9, x minus 9. The domain means I have restrictions on the input. What are those restrictions? Well, x is an element of real numbers, but x cannot equal plus or minus 9. If it does, it's undefined. Nothing cancels, therefore x equals -9 and x equals +9 are my vertical asymptotes. Nothing cancels, so there are no holes. Horizontal asymptote. Well, this is an x squared, so I'm going to have y is equal to 0x squared in the numerator and 1x squared in the denominator. Simplifying, that tells me my horizontal asymptote is y equals 0. My slant asymptote, I don't have one because I have a horizontal. X-intercepts. Well, if I set y equal to 0, notice the numerator will never be 0, so I don't have one. Okay. If I set x equal to 0, because that's where I get my y-intercept, I'm going to have y is equal to 1 over -9, which means my y-intercept will be 0, -1/9. With all that information, I graph it. Now, unfortunately, the cover-up graph that I used here, I didn't give myself to -9 and +9. So I'm just going to reveal it. Okay. Oops. And my bad. That's what happens when you're trying to rush through. This was a difference of what? See, if we were in class, you all would have helped me out. This is a difference of squares, and when I factored it, I should have 3 and 3, 3 and 3, plus and minus 3. Sorry about that. And here, let's do it with blue so you can sort of see a little bit better. There are my vertical asymptotes, and here is my horizontal asymptote. And then this guy, it's hard to see, but notice I'm not right at 0, 0. It's just a little bit above, but it's pretty darn close. Okay, or sorry, it's just a little bit below. All right. Now, if we continue, oops, didn't want to go, to example 3, my domain. Okay, notice that x plus 4 cannot equal 0, so x cannot equal -4. Domain, x is an element of reals such that x does not equal -4. Nothing cancels, so x equals -4 is my vertical asymptote. Here's my asymptote. Holes, nothing canceled, so there are none. Horizontal asymptote. Y is equal to 0x, I don't have any x's, over 1x. That means y equals 0 is my horizontal asymptote. I go graphing that guy. My slant asymptote, there is none because I have a horizontal. X-intercepts. Y, if I make y 0, y is equal to 2 divided by something, that means I'm never going to get 0. So there is none. And notice my horizontal asymptote. My vertical asymptote says that I put 0 in for x. So y is equal to 2 over 0 plus 4, which is 1/2, or 0 and 1/2. 0 and 1/2. And if I've lined these lovely graphs up right, boom. Okay, notice a lot of your questions are going to be about where are the asymptotes. If you graph this, you'll be able to see it on your calculator, which you won't be able to find the horizontal asymptotes. The vertical asymptotes, if you look at the table, you can find where there's an error. For which axis is there an error? That can be easier or harder depending on whether or not it's an integer or if it's some crazy fraction. Okay. Next up, example 4. My domain. Well, x plus 1 cannot equal 0, so x cannot equal -1. Domain, x is an element of real numbers such that x does not equal -1. The curly braces say that it's set notation. My vertical asymptote is at x equals -1. So here's -1, and there's my vertical asymptote. My holes, nothing cancels, so there are none. My horizontal asymptote, y equals, now here I have -x over x. They're the same degree. So this is just -1. Y equals -1 is my horizontal asymptote. There goes the horizontal asymptote. Slant asymptote, there is none. Okay? And you won't see very many of the slant asymptotes. It's something that you're learning about, but you really need to get down the vertical and horizontal first. X-intercepts, well, if I make y equal to 0, then that means the numerator has to be 0. So 0 is equal to -x minus 3. Add 3 equals negative x. Negative 3 is equal to x. X-intercept occurs at negative 3, 0. Y-intercept, that's when x is 0. So y is going to be equal to 0 minus 3 over 0 plus 1 is equal to negative 3. 0, negative 3. So 0, negative 3 is my y-intercept, and negative 3, 0 is my x-intercept. Now, again, you could go, and I'm going to skip the part where you look up all the points in a table. You want to go back and look at number 1 for that. And you can plot a couple of the points. Okay, you find that negative 2 is here, 1 is about here, and you can then sketch in your curve, which is the red. The red curve there is the actual curve of the function. The blue dashed lines are guides. They guide the curve. Those are your asymptotes. We are up to example 5. Okay, you've got the domain. Ooh, before I can start doing the domain, guess what I've got to do? I have to do a little factoring. In the numerator, I have a common factor, x. X times x minus 4. In the denominator, I can take out a negative 2. That leaves me with x squared plus x minus 6. Ooh, but I'm not done in the denominator, so I have to keep going. So the numerator is x times x minus 4, and the denominator is negative 2. And then we need factors of negative 6 that add up to positive 1. So that's going to be x plus 3 times x minus 2. Now, I look, nothing cancels. Since nothing cancels, I will not have a whole. The domain, x cannot equal negative 3, x cannot equal 2. So therefore, my domain, notice if x is negative 3, denominator is 0. If x is 2, the denominator is 0. X is an element of real numbers such that x does not equal negative 3, x does not equal 2. My vertical asymptotes, nothing cancels, so my vertical asymptotes occur at x equals negative 3 and at x equals 2. I go in and I can draw in my vertical asymptotes, and at 2. Okay. Now, horizontal asymptotes. I've got squared over squared. Great. Y is equal to 1 x squared over negative 2 x squared. The x squareds cancel, leaving me with negative 1/2. So y equals negative 1/2. I don't have a slant because I have a horizontal. My horizontal is at negative 1/2. A little harder to graph that in with the pen. Okay, now x-intercepts. That means y is equal to 0. So 0 is equal to x times x minus 4. So I'm going to have two x-intercepts at x equals 0 and at x equals 4. So x equals 0 and at x equals 4. So it's going to be 0, 0 and 4, 0. My y-intercepts, that's when I plug 0 in. So now I plug 0 in. 0 minus 4 times 0 is 0. All over 12 is 0. So it's just 0, 0. Okay, now take out your calculator, go to your table. When you plug this in, make sure you put parentheses around your numerator and parentheses around your denominator, and you get some values. You plot a couple of values in each section. That means in the left and in the center and in the right. and connect those points, and boom. And your graph will look like this. How are you doing? Okay? Okay. Continuing on, I have a work on independent practice. Solutions will be revealed soon. What I'm actually going to do is split this into 2 lessons. This first one being 25 minutes long. The second one will be just the independent practice solutions. So go ahead and work on those and see how you do. I realize the holes and the slant asymptotes might be a challenge, but see if you can figure them out, and if not, it's okay. Just know that there's a slant or know that there's a hole, and watch when we do the practice. Okay? That's it.